Assalamualaikum warahmatullahi wabarakatuh and good morning Dr. Ri. So today we are going to present about our project of high voltage engineering. We are from section 2 and group 6. So we have provide to create insulator design and HVA wet and dry testing for our insulator. So our group member is consists of 4 members, which is the first one is Nik Ahmad Saleh bin Muhammad Taib. The second one is Muhammad Asrul Aiza bin Hadi, which is me. And the third one is Dam Filatina binti Hashim. And the last one is Roshada binti Muhammad Arifin. So for the company background, I will explain about our company background. Uh, as you can see here, this is our logo for the company background, which is FYS means for your safety Sendirian Berhad company. We have created consists of 4 members, and it's such a limited members for our company. So it's Sendirian Berhad, and this our motto: safety is a choice our make. This means our company are really take note about the safety, and we are going to improve our safety for our insulator design. So our company only design an insulator, provide and better insulator. So we move to the next slide. So this is me as a project manager, which is Muhammad Asra Aizam bin Mahadi, and the second one is Ni Ahmad Salim binti Muhammad Tan as electrical engineering, and Roshada binti Muhammad Arifin as a designer engineer, and the last one is Dam Filadina bin Hashim as a mechanical engineer.
So let's get started with the introduction of this project. We are from FYS Insulator Syndrome Berhad are required to design an insulator. As we know, insulator has the function in electrical part and mechanical part. For electrical part, we it is used to uh, resist the current flow through the conductor. Meanwhile, for mechanical part, it is used to give the support to the conductor despite its weight and any additional loads. So in this project, we are required to design the insulator for extra high voltage in 132 kilowatt, and then the type of insulator is suspension type in overhead line. So in designing the insulator, we need to consider several things. So the first one is material properties. Um, there are a lot of things. There are a lot of materials. So like in insulator, there are sheet and fittings and core of the insulator. This is so important to ensure that the non-conductive material can resist the current flow. And then for electrical properties, it is very important to have a higher electrical resistive uh, to minimize the current leakage. And then for mechanical characteristics, this is so important uh, in terms of the size, the diameter, to give the good support for the insulator. So now let's go through to the objectives of this project. The first one is to simulate the high voltage and electromagnetic fields distribution by using finite element method magnetics FEMM software. This is one of the software in FEA. And then the next one is to analyze the performance of the prototype, our insulator, when stressed by environmental impact using FEMM software as well. And then the last objective that we need to achieve is to be able to work efficiently in a group in solving engineering problems related to high voltage in a given time. Okay, once we come out with the design of the insulator based on many aspects that we need to consider, the material, the size, the diameter. So we use FEMM software to firstly simulate the HV and EM field distribution. And then the second one is we use this software to analyze the performance of the insulator model.
So I will proceed about the material of concept design. So as you can see here, you can see that our design for the insulator, which is we have 13 discs. Each disc have 11 kilowatt, 11 kilowatt, and the rod on the center of the disc is made by fiber reinforced rod, FRP, and the disc made by silicon rubber, and the hole made from the steel. So the next one is our 3D design. So this 3D design made from our designer using AutoCAD. So as you can see here, by design and 3D insulator, you can see from the top view, from you, from the side view, you can see more other view in the AutoCAD software. The next one is 3D design of the sizing of the 3D design. So the sizing is, as you can see here, the largest disc is 214 radius, 214 diameter, and the smaller disc is 174 diameter, and the rod is 22 diameter, which is uh, 11 radius equal to 11 millimeters. So this is equal to millimeter per unit. So you can see here the space between the large and the smaller. This is 30 millimeters. So I will proceed to the next slide, which is about our simulation. So our simulation are using the FEMM software, which is we need to consider the boundary, the conductor, and the materials. So we are using the axisymmetry, the boundary condition is the open boundary, and the properties of conductor, which is we are setting the our insulator in the transmission line for the 132 kilowatt, and the ground is 0, and the material permittivity is the air is 1, the silicon rubber is 4, the FRP is 5.6, and the steel is 1, and the wet condition for the disc is 80.4, and the dry condition is 1. So these properties will be including the setting properties in the FEAM that will explain the result later. And I will proceed to the flowchart of our project. As you can see here, we start the project by study the insulator, study the type of insulator. And then we collect the data, literature review of the other research of the previous research, and we design our own insulator based on our studies, that the best material, the good condition for the insulator, and the type of metal insulation. And then we design the insulator using the AutoCAD in the 3D modeling, and we design 2D drawing in the FEAM software to analyze the voltage field and electrical field. So you can see here, if the two design in software, we analysis if the success will be proceed to the data collection, and if the analysis are not successful, we'll be rotate to the 2D design and design back the insulator until we get the proper result. So I'll proceed about the block diagram for the simulation process. So for the simulation process, uh, for the first thing that you need to do is you need to set in the problem, such as we are going to use the electrostatic problem, and the problem we set to the unit in millimeters, because our sizing of insulator in millimeters, and the type of problem is axis symmetry, which is we only draw half of the insulator to produce the field, and then we design the 2D design in the FEM software. We draw by the proper sizing, by the correct sizing, and then we set in the boundary, the material, and the conductor properties, which is here the properties we set in based on this value we set in here, and then after finish all the setting here, all the mesh, all the material, conductor, and boundary, we are meshing the 2D design, and if the success, we can run and display the result of the electrical field and voltage field. So the summary of methodology of the FEA simulation on our prototype insulator design. So the first one we need to do is must study, and the second one we design using the AutoCAD 3D design, and then we are using FEMM software to analyze the 2D design, to analyze the voltage field and electrical field, and then we are going to we obtain the data and analysis the data, and explain about uh, the result that we have using graph or figure. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Roshada binti Muhammad Arifin. Okay, next I will do the explanation about FEA simulation result and data observation. So this is our prototype that were designed by using FEM software, which is electrostatic problem. This is polymer insulator. This insulator consists of sheets and fitting for both side and core. So as for sheet, it is consists of 30 sheet, which is 6 for the large sheet and 7 for the small sheet. It is consists of 13 sheet because our transmission line is 132 kilovolt. So since the value for the one sheet is 11 kilowatt, so we need 13 sheets to obtain 132 kilowatt. So the material for this insulator is, the sheet is made of silicone rubber. The end fitting for the both side, which is top and lower, is made of steel, and the core is made of fiber reinforced plastic rod, which is FRP. This material consists of specific relative permeability, which is 4 for silicone rubber, 5.6 for FRP, and 1 for the steel. As for high voltage, we apply the value of 132 kilowatt at the bottom of the N15, and at the top of N15 we apply the ground, which is consist of 0 kilowatt value. Okay, next is prototype machine. So this is our prototype after we run the mesh analysis. As for the yellow region, it is the region that have been defined, and the gray region is the region that have not been defined. So as for the yellow region, we define it by using the basic material of our insulator, which is steel, FRP, silicone rubber, and air. As for the gray region, we will define according to the HVAC wet and dry test. So as for the material for the wet test, we will use water, and dry material for the dry test. Each of these material also consists of their own relative permeability, which is 80.4 for water and 1.000536 for the dry material. Next is voltage distribution. So this is the result of voltage distribution for the simulation. we do the two tests, which is dry test and wet test. So so this one is for dry test, which is clean condition and contaminate condition, and this is for the wet test, which is clean and contaminate condition. So as for the clean condition, we use air as the material, and as for contaminant, we use cement as the material. So the value of relative permeability for the air is equal to 1, and for the cement is equal to 2.8. So from the result, we can conclude that the contaminant condition consists of high voltage distribution than the clean one. So as we can see here, the contaminant condition for the dry test consists of the most highest voltage distribution than the others result. Then is the voltage distribution along trippage distance. So this is the result for the HVAC wet test, and this is for the dry test. So from this four graph, the voltage distribution is uniformly distributed and gradually increase from the high voltage end to the voltage end. So as for the HVAC wet test, the voltage distribution for contaminant is higher than the clean one, and as for the HVAC dry test, the contaminant condition also higher than the clean one. But for the wet test, this area we can see it is decreased just a little bit. But for the dry test, the value of the voltage distribution decrease and then increase. So from this four graph, we can conclude that the contaminant condition effects of increasing voltage magnitude along the insulator surface. Okay, next is electric field. So this is the simulation result of electric field for the HVAC dry test insulator and HVAC wet test insulator. So this area is the clean condition, while this area is the contaminant condition. So as for the dry test insulator, we can see the contaminant condition has the highest electric field compared to the clean condition, and we can see here at the low NPT it has more electrical field since we apply 132 kilowatt at this area, while this area consists of the lowest electric field since it is the ground and it has 0 kilowatt as the voltage value. So the result for the both dry and wet test is a bit similar, which is we can conclude that the contaminant condition has the higher electric field than the clean one, and the counter for the contaminant is more than the clean condition. So this is the result of the trippage distance for the electrical field for the HVAC dry and wet test. Okay, so this is the graph for the wet test, and this one is for the dry test. So from both of the tests, the graph is quite similar for the clean and contaminant. So it can be concluded that the value of electrical field strength is higher in contaminant condition than in the clean one, since we can see the electric field for the contaminant from the graph is a bit higher than the clean one. This is the clean one and this is the contaminant. So That's all from me.
Assalamualaikum, my name is Ni'amat Salam bin Muhammad Taib. I will present about the brief analysis of FEA simulation result and data observation. Uh, in this test, there are several conditions that has been tested, namely dry and clean, dry and contaminated condition, wet and clean condition, and wet and contaminated condition. These tests are conducted separately, namely dry condition test and wet condition test. The results of the test on the dry and clean condition show that the voltage potential for the dry and clean condition is lower than the voltage potential test found on the insulator for the dry and contaminated condition. This test show that when the insulator is a dry and contaminated state, it will cause a higher voltage value than when the insulator is in a dry and clean condition. The voltage condition on the graph shows that the voltage start rising from creepage distance 0 mm to 4000 mm and decrease at the distance before reaching 5000 mm and sharp rise at the creepage distance uh, at the creepage distance 5000 mm. This condition is similar to the above test, which is test dry and clean condition and test dry and contaminated condition. The higher value in the dry and clean condition is 15 kilovolt, and the higher value in the dry and contaminated condition is 20 kilovolt. The wet condition test shows that the result of the test on the wet and clean condition that show that the voltage potential is lower than the voltage potential test found on the insulator for the wet and contaminated condition. The graph shows the voltage distribution along the creepage distance at wet condition. This graph obtained on the test result of the wet condition show a very similar situation to the dry condition, but there are some difference in the dry state indicating the voltage distribution along creepage distance is more severe than the wet condition. The graph shows that the voltage did not rise as sharply at the 5000 mm as sharp in dry condition. In dry condition, the voltage rise sharply at 5000 mm, and the wet condition, the voltage did not rise as sharply at as dry condition. This indicates that when the insulator is in wet condition, the voltage distribution along creepage distance will be lower than the dry condition. Next, for electric field strength distribution of HVAC test, in this test, it also have several conditions that have been tested, namely dry and clean condition, dry and contaminated condition, wet and clean condition, wet and contaminated condition. These tests are conducted separately, namely dry condition test and wet condition test. The result of the simulation have been shown that the electric field strength of the insulator is higher when dry and contaminated in a dry and clean condition. In wet condition, the value of the electric field strength is indicates that electric field strength is also higher in the contaminated condition than in clean condition. The graph obtained from the simulation for the wet condition shows that the same condition, same results as the graph on the dry condition. We got the same result as in the dry condition. This will indicate that when dry condition or wet condition, the electric field strength of the insulator is the same. The difference we can see from this test is only during the clean and contaminated condition. That's all from me. Thank you.
So the conclusion that we got from FEA work is, firstly, we got to design an appropriate insulator by considering all the standard requirements. And then we also get to analyze the performance by doing the testing, HVA, dry and wet testing, by using the same software, FEMM software. And then we also get to learn the difference of each materials in designing the good insulator based on many things, many aspects. And then we also get to study how important it is for us to take care of our safety, especially in laboratory. And then we get to work as a team to complete this project.